I'm going to be going over some clarifications for Lab 1, Measurement and Uncertainty. So in Lab 1 you have Activity 1, where you're pretty much measuring the weight or the mass, of the plastic cups, plastic cup 1 and plastic cup 2 on your balance. And then in Activity 2, you are taking each of the 4 pieces of glassware, measuring out this amount of water, and you have 2 trials for each piece of glassware. And so in the original data table, it doesn't accommodate for trial 1 and trial 2. And so what some of you may have done is just draw a line down the middle and said trial 1, trial 2, which is fine. If you've already done the lab and you've done it this way, you're perfectly fine. This is just for people who haven't done the lab yet and need some clarification. And so there is an edited data table, which might make things just a little bit more clearer. This data table allows for one trial for each piece of glassware. So trial 1, trial 2 for 10 milliliters, and so on and so forth for each piece of glassware. And so there's still mass of empty glassware, volume of water, high and low volume, uncertainty, mass of glassware with water, and mass of water. And there's this extra row down here, which looks like, why are we putting in extra information? But this is actually just going to help you in data table 3. And so the average mass of water here is just the mass of water you got for trial 1 plus the mass of water you got for trial 2 divided by 2. And that's all that goes here. This number plus this number divided by 2. And this number here, is what's going to go in this box for data table 3. This is the original data table 3. That's what goes here for mass of water. We want the average mass of water for trial 1 and trial 2 for the 10 milliliter, average mass for the 50 milliliter, average mass for 25, and the same thing for the 250. And this data table 3 has also been edited, but the only difference between these two data tables is that this box just tells you where this number comes from line H, from this line in data table 2. So this isn't actually more work, it's just making it more clear where you need to fill in your numbers and how to do the calculations. And so I wanted to also focus on these 3 measurements right here. What is meant by high and low and volume and uncertainty? What is that? And so we go back to the background of the lab where it talks about, and I'm sorry this is hard to see, if you pull up your own lab it'll be a little bit more clear, about reading from the meniscus. And so you read from the bottom of the curvature for the liquid, but here the curvature is in between these 2 lines. And so what it's talking about here with a high volume and a low volume, you have to estimate, make a very good estimate about where the meniscus is in between these 2 lines. And so we are at 6.5, 6.6, 6.7, 6.8. And so each of these lines represent 0.1. And so it's somewhere in between 6.7 and 6.8 here. So it's like we kind of have to make a very good estimate here. And in the glassware that comes in the kit, they have less lines in between them. With the glassware in the kit, each line represents 0.2 instead of 0.1, just to make that clear. But in this picture, each of these lines represent 0.1. And so Your high volume is the higher estimate you have. Your low volume is your lower estimate for where that meniscus is for the measurement for the trial 1 in the 10 milliliter graduated cylinder. When you measured approximately 7 milliliters of water, it's exactly 7 milliliters is the meniscus in between those two lines. So that's what these numbers are about. And your uncertainty is just going to be your high volume minus your low volume divided by 2. So this number minus this number divided by 2. That's all this is. And so in data table 3, we already talked about where this number comes from. And so where does the current water temperature come from? Well, you measure that with your thermometer, of course. And then you're going to read this table and it's like, whoa, what the heck does this mean? So if I measure with my thermometer and let's say my temperature is 24.5. So I'm going to go to 24 and I'm going to go over to 0.5, right, 0.5, 24.5, my density is 0.9972. That's how you read this table. And so let's just say my temperature, is 24.5 degrees Celsius. That means my density was 24.5, 0.9972 grams per centimeter cubed. And I have a mass of water. I'm just going to make up a mass. This number's coming right off the top of my head, so please don't copy it or use it to make your calculations. Let's say I have 15 grams of water, or milligrams of water. Okay, so now I have the mass of water, I have the density. I don't need this temperature anymore, so do not use the temperature in the calculation of the volume. Density equals mass over volume. And so what you're going to do is you're going to plug in your density, you're going to plug in your mass of water, and calculate your volume for each piece of glassware. And that's how the calculations in the data tables for Lab 1 work.